Hi everyone. Today we are going to explain the last section of the chapter 5, talking about conditional probability. Condition, we mean is up to a condition, how we calculate the next probability to occur to something or to any outcome occurring when having or when a previous outcome is given. So normally, by definition, the probability that an event occurs given that another event has already occurred. So we are talking about multi-stages events, okay? So if, for example, so we are going to calculate and evaluate the probability of an outcome if in the second stage, if we have already another outcome occurred in the first stage. It's called conditional probability. So normally when we see this term given, if, so normally such that, so normally these are the keywords of conditional probability. And for example, if a die is thrown and the result is an odd number. So normally we have a if an odd number. So normally we are in the case where the sample space that we should investigate and should work in is about or contains only the odd number. Okay, we have a condition because we have a if, so we will talk about conditional probability, and the result or the probability that we are searching for is related to the outcome of the first stage with odd numbers. So normally the new sample space where we will work in is contains only the odd numbers of the faces of a die. So normally the effect of the condition is to reduce the sample space. There are only 3 odd numbers possible, so the new sample space or the new reduced sample space contains only 1, 3, and 5. And when they ask us, then they ask us to find the probability that it is a 5. 5, but not from, for example, 5, the probability of 5 is 1/6 if we are talking about normal probability without any condition. But when this probability is related to the condition that the result is an odd number, so that's reduced sample space contain only 3 numbers. One of these outcomes is 5, so normally 1 from 3. So we should find the reduced sample space and identify the favorable outcome, because we know that the probability is equal to the favorable outcome over the number of possible outcomes. We have 3 possible outcomes. We have one favorable outcomes because 5 occurs once among 1, 3, and 5. Also, a family had 4 girls. The probability that the 5th child is a girl is 1/2. Yes, of course, because here each time when you have when a child is born is independent from the other, from the next, from the previous event. So normally when the sex of the 5th child is independent, and we know that we have a probability of 50/50 to obtain girl or boy. So 50, so 1/2 is true. At the toss, the captain of the cricket team has called heads 5 times in a row and lost. The vice captain says to call heads again because it is overdue. No, of course, this statement is not valid because there is still an even chance of heads or tails. So even chance, because if each time is independent. Each task is independent from the others. And also keep in mind when working with conditional probability, we should find first the reduced sample space and identify the favorable outcomes to in order to calculate properly and correctly the probability of any outcome. So, for example, in the fifth exercise, a die is thrown and it is known that the result is a number less than 5. Okay, what are the faces less than 5? We have a 1, 2, 3, and 4. So normally the reduced sample space is 1, 2, 3, and 4 because we are talking about a new sample space. Then when calculating the probability that it is a 3, so normally 3 occurs once between these, among this one. So normally 1 from 1, 2, 3, and 4. So 1 of from 4, the probability is quarter. Okay, a card is selected at random from a normal pack. We have a normal pack contains the normal pack of cards, contains 52 cards. We have a 13 of each type. We have a 13, we have a 26 blacks and a 26 red, where 13 hearts, 13 diamonds, 13 I think picks, and the 13 of the fourth types. Okay, and in each type we have a only 3 pictures. So a queen, a jack, and I think the king. Okay, so normally to calculate the probability that it is an ace given that is a heart. Normally, this is the condition. So from this condition, we deduce our reduced sample space. So it is a heart. Okay. How many heart cards we have in a normal pack? We have a 13. So we have a 13 cards, heart cards. Okay. The new reduced sample space contains 13 hearts. And in a 1 ace, we have 1 from this type. We have a 1 ace, so 1 from 13. Good. A king, given that it is a black, we have a 26 blacks cards because we have a half black, half red in the normal pack. So the reduced sample space contains 26 cards, and we have a 2 kings because 1 of each type of a black card. So we have a 2 from 26. So after simplification, we obtain 1 over 13, and so on. So it is very easy to find and to find the main idea of conditional probability. We have a condition. From this condition, we deduce the reduced sample space. Then we complete to calculate the probability using the same formula, number of favorable outcomes over number of possible outcomes. 2 dice are rolled. If the sum of 2 numbers is 7, what is the probability that the numbers are 1 and 6? So because 2 dice are rolled, so normally we have a 36 different outcomes. Okay, with 6 couples, for example, double couples like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. And we have here the order matters because the couple 1, 2 is different from 2, 1. Okay, if the sum of 2 numbers is 7, how to obtain the sum of 2 numbers of 7? We can draw the net diagram to obtain the 36 to find out what are the 36 different couples and outcomes of rolling 2 dice, and finally we can check if the sum of 2 numbers occurred equal to 7 or not. So we will obtain the reduced sample space as 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, 4, 3 only. So we have as favorable outcomes, we have 1, 2, if of possible outcomes, we have 1, 2, 3, 4, 5, and 6. And we want to calculate the probability that the number are 1 and 6. We have here 1 and 6, and we have here 1 and 6. So normally we have 2 favorable outcomes over 6. After simplification, we'll obtain 1 over 3. Okay, so easy to get it. The table shows that collected from 100 male year 10 students. Okay, we have 100 males. Here we have 100 students, and we wanted to investigate about two different subjects due to maybe two independent subject also. Does not always dependent subject, like we explained before with the product rule. Maybe in the most cases we use the product rule in the case of independent event, but it is not false wrong to use it when we have a dependent event, but we should be aware about the consequences of replacement and without replacement one. Okay, we have the table show that collected from 100 males, year 10 students, year 10. So we have 100 students. Okay, we want to ask them if they wear glasses or not, and if they are left-handed or right-handed students. So the two subjects are totally independent, and so if we can, for example, we can read clearly, or we can see clearly that we have 49 students that wear glasses. And from this 49, among these students, we have 14 left-handed and 35 right-handed. We have 51 as a total of students who don't wear glasses, and among them we have 42 right-handed and 9 left, only 9 left-handed. We can read it differently. We have a total 23 of left-handed students. Among them, we have 14 wearing glasses and only 9 not wearing glasses, and so on. As a whole, we have 100. If we add it like that, or we add the total in column, we will obtain 100 students, because we have investigate 100 students. If one of these students is selected at random, what is the probability that he wears glasses, given that he is left-handed? So normally, given that he is left-handed, so we are working with left-handed only. How many left-handed students we have among 100 students? Normally, the total of left-handed students is 23 students. So normally the new reduced sample space contains 23 students. So normally from 23 we are interested on the students wearing glasses. So we have among them we have 14 wearing glasses, so 14 over 23. So easy also to know and to catch simply the idea. Okay. A bag contains 3 red balls, 2 black balls, and 1 green ball. So normally we have 3 red, 2 black, 1 green. Okay. In total, we have 6. 1. 2 balls are chosen at random from the bag, one after the other. Also, we can investigate the conditional probability when with replacement and without replacement. The first ball is replaced before the second ball is selected. When the first ball is replaced, so normally we have the same conditions, and we have the same balls in the bag. So normally nothing is different from the original situation. We have the same situation when we are selecting for the first time or for the second time. Okay, so we want to find if the first ball chosen is red. So normally, if the first ball chosen is red, so what is the probability? The first chosen is red, and also we replace it to in the bag. So what is the reduced sample space? We again have the same number of balls. So the reduced sample space is the same that we have in the original, in the first selection. Okay, we have 3 balls because what we chose we simply replace it in the bag. So we have a 3 red, 2 black, and then 1 green, and we want to obtain secondly red because we chose red, and to have 2 red balls, so the second one is red. So the probability to obtain red as a second is 3 from 6, is 1/2. And also a red and a black, when we obtain the red firstly, so the second one is a black. What the probability of obtaining the black as a second? So 2 from 6, and so on. But without replacement, when we the first ball chosen is red, so normally the reduced sample space that we have, the reduced sample space is 2 red become 2 red, and 2 blacks remain 2 blacks, and 1 green remain 1 green. So we have in total 2 plus 2, 4, 4, 5. So the reduced sample space contains only 5 balls instead of 6. So normally we want to work with 5 balls only, and among them we have only 2 red balls instead of 3, because we chose in the first selection we chose the red, so and we didn't replace it before the second ball is selected, and we want to select the red as a second. The probability of selecting red as a second, so we have a 2 red from a 5. Black as a second to obtain 1 red, 1 black. So the second is black. So the second is black 2 from 5, and the balls of different colors. So normally, so we should select one of the others, because red is chosen. We can choose another time a red. So normally different color from black or green from the other. So not red as second, not red. We have a 2 plus 1, or not red. So 3 from 5. I think these are the important idea of our lecture. Thank you for watching, and have a nice day.